In the twilight of our scientific age, man stands on the brink of a world breakup. The promise of interstellar travel, once the stuff of great science fiction, now rings with the brilliance of fashion. Imagine a future where the stars are no longer far away, where the light is unreachable, but where travel is almost breathtaking. This is the dream of faster-than-light travel, FTL, a concept that has captured the imaginations of scientists, engineers and visionaries. With the advances of the past, we may be closer to this dream, even if the road is filled with deep challenges and uncertainties. Theoretical approach. From relativity to relativity. The concept of faster-than-light travel has long been limited by the strict limitations of Einstein's theories of relativity. According to Einstein's special theory of relativity, when an object approaches the speed of light, its mass increases and it has an infinite amount of energy to continue its acceleration. This is a major obstacle to any body trying to reach or exceed the speed of light. The speed of light, about 300,000 km/s, as a universal equation, is an unbreakable threshold in our current understanding of physics. Warp drives, a concept popularized by science fiction, offer an exciting solution to these limitations. Rather than propel a spacecraft through space, warp propulsion proposes to warp spacetime. The theory is that by contracting the space in front of the spaceship and expanding at the back, the spaceship could travel faster than light in space outside the warp bubble without reaching the speed of local light. This approach ignores the issues of relativistic mass accretion and the energy requirements associated with traditional deposition methods. Miguel Alcubierre, pioneering warp drive concept. The concept of warp drive technology was established by Mexican physicist Miguel Alcubierre in 1994. Alcubierre's proposal was based on the concept Einstein's general theory of relativity, which describes the existence of mass and energy. Eliminate time-space. Alcubierre thought he could make the light travel faster through the bubble by creating a blur bubble that contracts the space in front of the spacecraft and expands behind it. The ship remains in a bubble, avoiding the relativistic effects of traveling at near light speed. However, Alcubierre's theoretical framework is not without its challenges. The energy required to generate and maintain such an expansion bubble is staggering, possibly equal to the energy of the entire mass of a star or more. In addition, this theory relies on the existence of unusual and dense negative energy, a type of matter that has never been discovered or created in a laboratory. The search for alien matter, the inevitable element. The need for alien matter to have negative energy density is one of the biggest challenges in tumor research. Negative matter is a negative energy density, so that it can counteract the negative effects of normal matter. This foreign material may create a permanent strand bubble. Despite a great deal of theoretical work, no evidence of harm was ever found, and life was taken for granted. Besides the conceptual challenges, creating and manipulating extraterrestrial materials on a scale sufficient to power a warp drive presents significant difficulties. Current technologies and resources are insufficient for this task, forcing researchers to explore other solutions and ways to avoid the need for harmful substances. New trends, new methods and experimental research. Despite these challenges, progress continues to travel faster than light. Researchers are exploring other theoretical frameworks and empirical methods that will bring us closer to realizing the dream of space travel. One notable development was the work of Dr. Harold "Sonny" White, a former NASA physicist who made significant advances in space divergence research. Dr. White's research focuses on the Casimir effect, an important phenomenon observed between two metal surfaces. The Casimir effect creates small differences in the vacuum between the layers, creating Casimir holes. Dr. White has identified gold bubbles in these holes and provided a blueprint for building gold bubbles on a larger scale. His work has attracted interest and funding from organizations such as the Defense Advanced Research Projects Agency, DARPA, which invests in further research to explore the practical applications of these findings. Dr. Eric Lent, a new approach to warp technology. Dr. Eric Lent of the University of Jingen has proposed a new approach to warp drive technology. Unlike previous models that rely on negative factors, Lent's approach uses the best-known energy density. This means using solitons, local waves that can generate warp bubbles without the need for external objects. Lentz research marks a major turning point in the search for faster-than-light travel, which may overcome some of the most difficult limitations of previous theories, the limits of current technology, from space to intermediate travel. As scientists explore these scientific and experimental advances, it is important to consider the state of our space exploration technology. The fastest spacecraft to date, such as the Parker Solar Probe and Voyager 1, travel as fast as the speed of the Moon. For example, the Parker Solar Probe reached a speed of 191 km per second, which is only 0.02% of the speed of the Moon. Likewise, after more than 35 years in space, Voyager 1 has traveled more than 21 billion kilometers and reached the edge of the solar system. These current trends show how wide the gap is between our current state of technology and the prospect of interstellar travel. The distances between stars are so great that even our fastest probes take decades or centuries to travel the short distances on a planet. The hope of reaching other star systems in humanity's lifetime remains a distant dream without advances in artificial intelligence technology. The future of interstellar travel, opportunities and challenges. The dream of interstellar travel is driven by the desire to explore beyond the universe and understanding one's place in the world. Making this dream come true will require not only advances in warp drive technology, but also fundamental changes in the way we approach space exploration. This includes developing new energy sources, refining conceptual models and tackling the practical challenges of building and operating advanced distribution systems. As research continues, scientists and the public continue to speculate about the potential for faster-than-light travel. The opportunity to visit other star systems, explore new worlds, and expand human habitation on Earth is a powerful incentive to continue innovation and discovery. Pursuing warp drive technology is more than a scientific challenge. It is a journey into the unknown that can change our understanding of space, time, and the nature of reality. The road ahead, embracing the unknown as we enter a new era of space exploration. The journey to travel beyond the Moon is just around the corner. Although significant challenges remain, advances in theoretical and experimental research offer hope for a future that is possible for the stars. To dream of traveling between the stars is a symbol of one's intelligence and pursuit of knowledge. The path to faster-than-light travel requires collaboration across scientific disciplines, technological innovation, and a willingness to embrace the unknown. As scientists continue to push the boundaries of what's possible, perhaps one day we'll find ourselves exploring the far reaches of the universe and realizing the worldview that has the stars are not a distant dream but a possibility. The future of space travel is not just about technology, but about imagination and passion. As we look up at the stars and imagine what lies beyond, we are reminded that the pursuit of knowledge and exploration is at the heart of the human nature. A journey to the stars is a journey into the unknown, and with each step forward we get closer to a future where the impossible is possible, and the world becomes a playground for us. As we stand on the brink of the greatest scientific leap in human history, the forces of space faster than light invite us to think about time, a future where the barriers of space and time have been redefined. Each advance, from Alcubierre's bubble to new approaches to solitons and Casimir holes, represents a move beyond the limits imposed by our current understanding of physics. The exploration of these concepts not only challenges our grasp of the universe but also inspires a profound sense of wonder and possibility. The journey to achieve faster-than-light travel is as much about expanding our horizons as it is about pushing the boundaries of technology. With every discovery and every theoretical advancement, we are reminded of the boundless curiosity that drives us to explore the cosmos. As we delve deeper into these mysteries and confront the challenges that lie ahead, the promise of interstellar travel becomes more than just a distant dream. It becomes a beacon of hope, guiding us toward a future where the stars are not just points of light in the night sky, but destinations within our reach. The quest for faster-than-light travel embodies the spirit of exploration and the relentless pursuit of knowledge that defines humanity's journey through the universe.